Have you ever really stopped to think about what happens when you click on something? I mean, how that simple action sends information flying across the world and back, literally in the blink of an eye? It's kind of mind-blowing. So today, we're going to follow one single data packet on its incredible journey. Let's do this.
So yeah, this is the big question. How does it all actually work? We're going to break down this whole complicated process into a really simple step-by-step story. And by the end, you're going to see this hidden dance of hardware and software that makes our modern internet even possible.
You know, every big journey has to start somewhere. And for our little data packet, that first step happens right inside your own home or office. It starts on what we call the local network. This is its home turf, its neighborhood.
The very first piece of gear our packet is going to meet is a switch. And the best way to think of a switch is like a local traffic cop. Its entire job is to direct traffic within a single network. Making sure your computer can talk to your printer or that your laptop can see your smart TV. The key thing here is a switch only knows about its own little neighborhood. It doesn't know anything about the great big world outside. Okay, to really get this, you have to know that every device has two different kinds of addresses. You've got your MAC address, which is like your name. It's permanent, it's unique to that piece of hardware. Then you have an IP address, which is more like your mailing address. It can change depending on where you are. And our little traffic cop, the switch, it only cares about your name, the local MAC address.
So how does your computer find another device in the same neighborhood? It's actually pretty simple. It basically just yells out to everyone connected to the switch, "Hey, who here has this specific IP address? I need your MAC address." The right device hears that call, recognizes its IP, and sends a message directly back saying, "Yep, that's me. Here's my name." That little back and forth is called ARP, the Address Resolution Protocol.
Okay, but what happens when the destination isn't local? Our packet looks at the destination IP address and realizes, uh-oh, this address isn't on my street. It can't just shout anymore. It needs to find an exit. It needs to get on the highway.
And that is where the router comes in. So if the switch is the local traffic cop, the router is the neighborhood post office. Its whole reason for being is to take packets that are trying to get to other networks, other neighborhoods, and send them on their way. It's literally the gateway to the rest of the internet.
So here's the really important part. Every single device on your network knows the address of something called the default gateway, and that's just a fancy name for your local router. The second your computer sees a destination IP address that it doesn't recognize as local, it doesn't even try to find it. It just hands the packet over to the router and basically says, "Here, this is for the outside world, you figure it out." All right, our packet has made it to the router. The router grabs it, takes one look at that final destination IP address, the one way on the other side of the planet, and it gets to work. Its job is to check its map and figure out the very next step, or the next hop on this long journey. And this right here? This is the router's brain. It's called a routing table. Now notice, it's not a list of every single computer in the world. No way. It's a road map of entire networks. For every major destination network it knows, the table tells the router exactly which direction to send the packet to get it one step closer to where it needs to go. But what happens if there are a couple of different routes in the table that could work? Well, the router has one simple, unbreakable rule. Always pick the most specific path. It's like this. If you have directions to California and separate directions to 123 Main Street, Los Angeles, you're going to use the more detailed ones, right? The router does the exact same thing. It always picks the most specific address it can find.
Now, this next part is absolutely critical. Once the router picks the next hop, it basically repackages our packet. It strips off the old local delivery info, that's the layer 2 stuff, and puts on a brand new wrapper that's addressed to the next router in the chain. Think of it like the post office taking your package out of one mailbag and putting it into another one destined for the next city. The final destination on the box never ever changes, but the local mailbag does at every single stop.
Okay, this is all making sense, but wait a second. This brings up a huge question, right? How in the world does your little router at home get a roadmap of the entire internet? You know, an internet that is changing every single second of every day. Well, it's a mix of three things. First, it automatically knows about its immediate neighbors, the networks that are literally plugged right into it. Easy enough. Second, a network admin can manually program a route, telling it, hey, to get to this place, always go this way. But the real magic, what makes the internet work, is the third way, dynamic routing. Routers are constantly talking to each other, gossiping about the best paths they found, and instantly updating their maps whenever a road closes or a new, faster highway opens up. So let's just boil it all down. A switch is your local expert. It's super fast, super efficient at connecting devices inside one single neighborhood, using those permanent names, the MAC addresses. A router, on the other hand, is the global navigator. It's the smart device that connects all these different neighborhoods together, using those temporary mailing addresses, the IPs, to guide our packets across the entire internet.
And that brings us to one last thought to leave you with. For a long, long time, the roles have been crystal clear. Switches build the local roads, and routers build the interstate highways. But modern technology is starting to blur those lines. We're now seeing these powerful hybrid devices that can do both. They're called Layer 3 switches. So what does that mean for the future of networking, for speed, for design? Well, that's a question that engineers are answering right now as they build the next generation of the internet.